Hey geometry kiddos. So because I don't want to show you how to use your compass at home because that's just weird, I want you to start playing with constructions before we do them by hand. And there's this really cool website called Euclidea. So that's where I want you to go. And yes, you can giggle. I know it sounds like a disease. So it's just named after Euclid, and some poor schmo decided, hey, let's call it Euclidea. And apparently nobody had the heart to tell him, yeah, that doesn't sound so good. But anyways, I want you guys to go to the website Euclidea XYZ. So euclidea.xyz, and it'll take you right here. All right. Then from here, you're going to sign in. Now, I am going to sign in with whatever you want. You can use your school email. You can use a Google email. I'm going to use a Google email. Right there. Okay. So now I'm signed into Euclidea. When you scroll down, there's a button that says Play Now. Okay. And it is going to walk you through a set of constructions. Now, it's not going to explain how to do them. That's why I'm here. But I want you to see what it can look like before we start using the compass that I asked you to purchase. So I'm going to click here where it says Alpha. And here's my first thing. I have to make an equilateral triangle. It says construct an equilateral triangle with the given side. The construction must be exact. Guessing even very, very close doesn't count. Okay, cool. So if that doesn't count, what am I supposed to do here? Well, what I'm really supposed to do is I'm supposed to find a point that's up here and then connect the dots. But how am I going to find a point that's up here? So this is where constructions come in, and you need to think, well, that point up there needs to be right above the middle of the bottom, and it has to be the same distance from this as it is from that. I need to have all those distances be the same if it's an equilateral triangle. Okay, fine. So if that needs to be the case, what am I going to do? Well, I'm going to say, see, I'm hitting things. Sorry about that. I don't want to do this either. Sorry, hold on. Mrs. Weber's trying to learn how to use these things. I don't want those tools anymore. Go away. So if I need to figure out a way to do that, one of the best ways to get things that are an equal distance or equidistant away from other things is to use a circle. So that's why this circle tool is here. So I'm going to take this circle. I'm going to put my point right here. Okay. And then I am going to drag it. And notice how it kind of magnetizes down. I'm going to drag it over here. Every single point on this circle is this distance away from that point. So if I could only find the point that's directly above the middle, well, I've only said let's find all the distances that are the same distance away from the left endpoint. Let's do the same thing. Let's draw another circle, but start at the right endpoint. So I'm going to click on the right endpoint. Come on. There we go. And open my circle over to there. Hey, I think that's the point I wanted right up there. So I want to put a point there. So I'm going to come down here to the right, and that's the intersection tool, and it'll magnetize a point at that intersection. Bonk. Well, I don't see a triangle yet. I'm close. So now I need to use the segment tool to connect this to that and this to that. Okay, now I know you just watched me do it, but I want you to go through and do the same things on Euclidea that I'm doing right now. All right, so all three angles of a triangle are always 60 degrees. That's true. If I have an equilateral triangle, all the angles are 60. Now I'm going to click this right arrow to see where I'm supposed to go next. All right, you can receive one or more hidden V stars. Don't worry about that. Just hit OK. All right, I'm going to go to next. Construct an angle of 60 degrees with the given side. Well, if I want a 60-degree angle, I need an equilateral triangle. Okay, so I'm going to keep that in my head. I need to make an equilateral triangle. Well, if I need an equilateral triangle, and this line goes all the way, I need to give it an endpoint. So I'm going to give it an artificial endpoint right there. Now, I'm just going to build an equilateral triangle again. I'm going to open this up, boonk. I'm going to open this up, boonk. I'm going to create a point at the intersection, boonk. And then I need a 60-degree angle. So I'm going to create one side of the triangle. It already highlighted it yellow. Yay, I got my 60-degree angle. We have now constructed an equilateral triangle and then kind of accidentally constructed a 60-degree angle at the same time. Cool beans. What's next? If it's hard to hit the required intersection, there's a new Intersect tool. Okay, so they just want me to learn how to use this tool. All right, really quick, I'm going to go through this and I'm going to say, where do these two circles intersect? They intersect, if I highlight them both, at those two itty bitty points. Not a big deal. All right, here's an important one, and this is leading into what we're going to talk about this week, a perpendicular bisector. You've kind of already done what you need to do for the perpendicular bisector, because remember when we did that equilateral, I needed the point just like exactly above the middle. So I opened it to both endpoints and got a top bottom. That's what I'm going to do here. If I want the perpendicular bisector of this segment, I'm going to open all the way to here. I'm going to open all the way to there. And the perpendicular bisector would be this line going straight down. So now instead of connecting the endpoints to the top, I'm going to connect top to bottom. So I need to find the intersection of these two circles. And that gave me both of those points. And then I'm going to connect them with this. Ta-da! I found a perpendicular bisector. You're going to do that with your actual compass next week. All right. And one more. Now they gave me a perpendicular bisector tool. I mean, that's cool. So this perpendicular bisector tool just says connect the endpoints that you want to bisect, and it'll make the perpendicular bisector for you. Cool. Now, find a midpoint. Well, if I did the perpendicular bisector, it would have to go through the midpoint anyway. So if you want a midpoint, you just got to get the perpendicular bisector and show where the midpoint is. Okay, well, I want the perpendicular bisector between these two. Okay, I'm going to do this the long way. If I want to find the midpoint, I really want to take that segment, open from one side, open from the other side, see where the two circles intersect, draw the segment between them, and then see where these two lines intersected. Boom. I have a midpoint. Now, it's only going to give me two of the stars because I didn't use the perpendicular bisector tool, but I did it to remind you how it works. So that's what I want each of you guys to do. I'm going to go back here, and I want you to get through example 4, or at least get to, I should say, what calls example 4 here, circle in the square. If you think this is cool and you want to keep going, I bet you could do some of these other ones. If you get stuck, almost every single solution is somewhere on YouTube. You can just do Euclidea, circle and square, and it'll show you what process to take. So I'm going to sign off for now. Please, please, please go on Euclidea and try these on your own, because I think it's really going to go a long way in helping us do constructions with our actual compass this year. So I am going to sign off. I'm not going to sign off with a joke because honestly, the word Euclidea is enough of a joke as it is. So I hope everybody's having a great day, and I will see many of you soon.